Hello, welcome back to the channel. So let's continue our discussion on calculating the three approximations of this definite integral over here. So we have already covered midpoint rule approximation in the last video, and if you have not watched my previous video on the midpoint rule approximation, I would highly suggest you to first watch that video in order to get the full context of this question over here. So now, after calculating the midpoint rule approximation, we will calculate the trapezoidal and Simpson's rule approximation of this definite integral in this video. And before doing that, we'll go over the concepts of trapezoidal rule approximation and the Simpson's rule approximation. And the basic idea about these approximations is that whenever you have to calculate these approximations, there is always a pattern for the calculation of these approximations over here. And the pattern is you'll basically use the similar approach that you used while calculating the left and right hand Riemann sums. The only difference is the coefficients which are in front of your fxi's in this case. So in order to calculate the trapezoidal rule, what you do is you basically use the same formula for your delta x, which is b minus a over n. And in these approximations, in the trapezoidal rule approximation and also in the Simpson's rule approximation, you start with f of x of 0 in contrast to the right hand and the left hand Riemann sum approximations where you used to start with f of x1, right? So in these approximation, the trapezoidal rule approximation and also the Simpson's rule approximation, you start with f of x of 0. And then what you'll do is, in order to calculate your xi's, you use this formula, which is the same formula as your right hand Riemann sum formula, a plus I delta x. And then for the formula, what you basically do is, you can either remember this formula, or the easier approach is basically if you want to calculate the trapezoidal rule approximation, you first calculate delta x by 2, and then for the expression in the bracket, you start with your coefficient 1. So it would be 1 times f of x0, and then whatever terms you have afterwards, those terms will have coefficients 2. So it would be 2 times f of x1 plus 2 times f of x2, so on, and then you'll repeat this pattern until the second last term, when you will have basically 2 times f of x of n minus 1, and then for the last term as well, you'll have 1 as your coefficient, just like the case of x of 0. So for the last term, you'll have 1 times fxn in this case, and then you'll basically use this formula in order to calculate your trapezoidal rule approximation. This is basically similar to this formula. We just took this 1/2 constant out such that it had delta x by 2, and then your coefficients basically become 1, 2, 2, 2, 2, 2 until the second last term, and then for the last term as well you have coefficient 1. So you can either use this formula or this formula, whatever approach seems the most favorable to you. So now in this question, since we have to calculate the integral of this expression, integral from 0 to 30 of 1 upon x cube plus 1 dx, if we have to use the trapezoidal rule approximation, what we will do is we'll first calculate the delta x and xi's, and then we'll use the formula. So in order to calculate the delta x, we know that delta x is basically b minus a. B is your upper endpoint, a is your lower endpoint. So delta x is basically 30 minus 0 upon n is 6 in this case. So your delta x is equal to 5 in this question, and if you want to calculate your xi's using this formula, you will notice that your xi's will be these values over here. So your xi will start from your lower endpoint all the way to your upper endpoint with an increment of 5 units every time. And then you basically have to use the same formula for the trapezoidal rule approximation. We know that delta x is 5, and for the trapezoidal rule formula we do delta x by 2, and then we have this pattern, right? We start from f of x0 plus 2 times fx1 all the way to 2 times f of xn minus 1, plus the last one also has a coefficient of 1, right? So if we use this same formula with delta x as 5 in this case, it would be 5 by 2, and the inner expression would simply be f of 0 plus twice of f of 5 plus twice of f of 10, and the same pattern again, 15, 20, 25, and then for the last term you'll have 1 as your coefficient. So it would be 1 times f of 30 in this case, And if you'll calculate this expression over here, you will basically calculate the trapezoidal rule approximation for this definite integral over here. So now we know how to calculate the trapezoidal rule approximation. The next approximation is Simpson's rule approximation, which is also similar to the trapezoidal rule approximation. So you'll follow the same approach in order to calculate your delta x and xi's for your Simpson's rule approximation. The only difference is again your coefficients in front of your f of xi's expression. So in this case, the pattern is for your first expression, you again have your coefficient 1, and then you have an alternating sequence of 4 and 2's. So it will start from 1, and then you'll have 4, 2, 4, 2, 4, 2 pattern until the second last term, and then you'll have one coefficient at the end as well. A similar pattern like the trapezoidal rule, but instead of having 2's in between, you have an alternating sequence of 4 and 2 in this case. And then instead of multiplying this bracket expression with delta x by 2 as in the case of trapezoidal rule, in Simpson's rule, we multiply it with delta x by 3 in order to calculate this answer. So if we have to continue with the previous values, our approximation, the Simpson's rule approximation for this would be simply delta x by 3 times, again you'll start with coefficient 1 and then you'll have an alternating sequence of 4 and 2. So 4fx1 plus 2fx2, 4fx3, and then so on, and the coefficient of second last term will depend on whether it's ending with 4 or 2, and then for the last term you'll have the coefficient 1 again. So if you want to calculate the Simpson's rule approximation for this definite integral in the question, it would simply be, we know that delta x is 5, so 5 by 3 times f of 0 plus 4 times f5, 2 times f10, 4 times f15, 2 times f20, 4 times f25, plus the last term would have a coefficient 1, right? So the last term would be plus 5f30 in this case. And then again, if you'll calculate the answer to this expression, you'll calculate the Simpson's rule approximation for this definite integral over here, right? So I hope that makes sense. For both of these, trapezoidal and Simpson's rule approximation, you basically have to identify the pattern that we use in these formulas in order to calculate those approximations. So that's it for this video. Feel free to comment down on this video if you have any doubts. Follow the channel in order to get notified about the other videos that I'll be uploading. Stay tuned. Thank you so much for watching. Bye bye. Take care.